Welcome to this 9th video on trigonometry and the reference angle. We will explore how to solve for the reference angle for any given angle, no matter how large or small. Let's dive in. The reference angle is the smallest non-negative angle between the terminal side and the x-axis, assuming the angle is in standard position. It is always positive and acute, meaning less than 90 degrees, and always measured to the x-axis. Throughout this video, we will use a visual legend to distinguish the input or given angle, shown in blue, from the reference angle, which is the result or output, shown in pink. In Quadrant 1, the baseline, the reference angle, is the angle itself. For example, a 75-degree angle has a 75-degree reference angle. In Quadrant 2, we look for the supplement. The angle stops short of the straight line, or 180 degrees. To find the reference angle, subtract the given angle from 180 degrees. For example, 180 minus 145 degrees equals 35 degrees. For Quadrant 3, the angle has passed the straight line. We calculate the excess past 180 degrees by subtracting 180 from the given angle. For example, 220 degrees minus 180 degrees equals 40 degrees. In Quadrant IV, we find the gap to complete the full circle, 360 degrees. Subtract the given angle from 360 degrees. For instance, 360 degrees minus 300 degrees equals 60 degrees. Here is a cheat sheet summarizing the formulas for finding the reference angle in each quadrant. This includes the Quadrant I formula, Quadrant 2, Quadrant 3, and Quadrant IV. For angles beyond one revolution, either huge or negative, we use coterminal angles. First, unwind the angle until it is between 0 and 360 degrees by adding or subtracting multiples of 360 degrees. We can follow an algorithm. Start with the given angle. Normalize it to be between 0 and 360 degrees. Identify the quadrant, and then apply the correct formula to solve. Example 1 is a standard case with no unwinding. To find the reference angle of 158 degrees, we identify it as Quadrant 2 and apply the formula. 180 degrees minus 158 degrees, which equals 22 degrees. For Example 2, a large angle of 745 degrees, we first subtract 720 degrees, 2 rotations of 360 degrees, to get 25 degrees. This is in Quadrant Y, so the reference angle is 25 degrees. In Example 6, a large angle unwinding to a non-standard quadrant, 829 degrees. Subtract 720 degrees to get 109 degrees. Since 109 degrees is in Quadrant 2, we use the formula 180 degrees minus 109 degrees, resulting in 71 degrees. Example 4 involves landing in Quadrant IV. For 1045 degrees, subtract 720 degrees to get 325 degrees. Then apply the Quadrant IV formula, 360 degrees minus 325 degrees, resulting in 35 degrees. For negative angles, like in Example 3, reverse the direction. Add 360 degrees to minus 143 degrees to get 217 degrees. This is in Quadrant 3, so the reference angle is 217 degrees minus 180 degrees, which is 37 degrees. In a complex case like Example 5, finding the reference angle of minus 2101 degrees, we must add multiple full rotations to surface above 0. We need 6 rotations, or 2160 degrees. Adding this to minus 2101 degrees gives 59 degrees. Since 59 degrees is in Quadrant 1, the reference angle is 59 degrees. Be aware of common pitfalls. Never measure to the vertical y-axis. Reference angles are distances and must never be negative. Also, do not skip steps. Always unwind angles greater than 360 degrees first. To summarize the logic flow, Take the input angle, normalize it to 0 to 360 degrees, locate the quadrant, apply the correct formula, and determine the final reference angle. Here is the summary of what we have covered today. Take a shot. You now possess the algorithm to solve any angle and have mastered trigonometry. Thank you for watching this video. See you on the next one.